Okay, graphing piecewise functions, part 2. A function f of x is equal to x plus 2 on the interval x is less than -3. The expression 2x plus 1 on the interval -3 is less than or equal to x, which is less than or equal to 4. So that's the interval -3 to 4. And negative x plus 3 on the interval x greater than 4. So the first thing that we're going to do is set up our intervals. So we go to -3. X equals -3 is right here. And we're going to draw a dashed line and x equals 3. And then we're going to go to x equals 4. And we're going to draw a dashed line. And that's at x equals 4. So we have the interval less than -3. And on the interval x less than -3, we're going to graph x plus 2. On the interval -3 to +4, we're going to graph 2x plus 1. And on the interval greater than +4, we're going to graph -x plus 3. So just like in the last video, over here on the left side where we have x plus 2, we need to choose 2 points. They have to be in this interval less than -3. So -4, -5. And there's nothing special about those 2 points. They're just the 2 points that I chose to use as my x values. So I substitute -4 in for x. -4 plus 2 is -2. So I have -4, -2, and -5 plus 2, which is -3. So when x is -5, y is -3. So there's my 2 ordered pairs. So I go to -4 and down to -2, -5 down to -3. So -4, -2, -5, -3. Label those 2 points. Take a straight edge and there's my function, or my expression, graphed x plus 2. Now, here at x equals -3, that's an open dot because we have x just less than -3. Now, between -3 and +4, we're going to graph 2x plus 1. So I'm going to choose an x value and a y value. Now, because it's less than or equal to, I can use -3. And because it's less than or equal to, I can use 4. So 2 times -3 plus 1, -6 plus 1 is -5. So when x is -3, y is -5. So there's our ordered pair, -3, -5. When x is 4, y is 9. So there's our ordered pair, 4, 9. So I graph those 2 points. So I go to -3 and down to -5, and that is a solid dot on the line because of the less than or equal to. And it's also going to be a solid dot at x equals 4 because of the less than or equal to sign. So when x is 4, y is 9. So I label those 2 points, -3, -5, 4, 9. I take a straight edge and I connect those 2 dots. The expression 2x plus 1 is only visible from -3 to 4, only in that interval. It cannot pass those 2 dotted lines. Now the last interval, we're going to graph -3 or -x plus 3, and that's in the interval greater than 4. So I cannot use 4 because it's greater than 4, so I'm going to use 5 and 6. So -5 plus 3 is -2. When x is 6, I have -6 plus 3, which is -3. So my ordered pairs are 5 and -2, and 6 and -3. So I go to 5 and up to, or down to -2. So at 5, -2, 5, -2, and at 6, -3. Again, I take a straight edge and through those 2 points, starting at x equals 4. There's the line that represents -x plus 3. At x equals 4, an open dot because it's x greater than 4. It does not equal it, so it has to be an open dot. So there's the graph of the piecewise function x plus 2, 2x minus 1, -x plus 3.